Hey guys, we are talking about relations and functions today. A relation is just a group of numbers that are related. We use them all the time. They can be represented by graphs, tables, ordered pairs. There's other ways. That's what a relation is. A function is a special kind of relation. It's a special relationship between those numbers. So in order for a relation to be a function, there must be exactly one output for every input. Now don't sign off. We're going to talk about what that means. So if you're like, what the heck are you talking about inputs and outputs? Well, if you have ever taken an equation like y equals 2x plus 1, and you've plugged in numbers for x to get y. You've probably done this. If not, I'll link a video for you in the corner. But then I go ahead and pick, okay, I'm going to plug in 1 for x. When I plug that in, I get 3, and you can keep going, right? See how when I plug in 1, I got 3. I didn't get, oh, y can be 3, 4, and 5 when you plug in 1. No, when you plug in 1 for x, you get 3 for y. Now, if you haven't already, you are going to soon be plugging in numbers and you get more than one output. That's fine, that's a relation, but it is not a function. For it to be a function, there is just one output for each input. So if we look at these here, these are called like mapping charts or something. I don't know their official name. I'll pretend I do. These are mapping charts. So it's just showing me there's different ways we can show inputs and outputs. A lot of times we use X as the input and Y as the output. I say a lot of times, pretty much all the time. So get used to that. But this one, we're labeled input and output. So this is just saying my input is 1, I got 3. My input is 2, I got 7. My input is 3, I got 12. Input 4, I got 8. So each of those inputs only had one output. So yes, this one is a function. If we look at this one over here, you'll see we have 9. That input has an output of 11. 6 has an output of 10. 3 has an output of 11. Now you might say, well, oh, 9 had that output as well. It's okay if an output repeats, that can still be a function. It's if the input has more than one output. So if you look here, you see how there are 2 arrows coming from 3? That means this is not a function. No, it's a relation, but it's not a function. All right, if you come down here, we've got some tables. Same thing, it just looks a little bit different, right? So I could also map it if you like that way. So I could do the input of 2 had an output of 9. Input of 0, the output was 7. Input of -5, we got 6. Oh, and then another input of -5 got me 10. So see how that input has 2 outputs? That cannot happen for a function. So this one is not a function. It's a relation, but not a function. Then let's look at this one. This one, if I look at my inputs, do any of them repeat? No, I've got 10, 5, 0, -5, -10. None of those repeat. Now, again, I do have an output that repeats, but that's okay. It's still a function because none of my inputs repeat. So yes, this one is a function. All right, don't go away, because guess what? Sometimes you are going to see these questions with ordered pairs and also with graphs. If you need a more detailed explanation of any of these 4 types that we've done, I'll link a playlist in the corner. All right, here we've got ordered pairs. This is just like my mapping charts and tables here. It's just written differently, right? But I could write this as a map or as a table if I wanted to. What I'm really concerned about is my inputs or my X values. I want to see if any of them repeat, if any of them have more than one output. So I've got -4, -3, -2, -1, 0. There were no repeats there. So yes, this one is a function. Let's look at this one. I've got 5 as an input, 7, -2, 5, and 1. Did any of those repeat? My 5 repeated, and this one had an output of 10. This one had an output of 2. I cannot have 2 different outputs for the same input, so no, this one is not a function. All right, sometimes you'll see it as graphs. One option here is to write down these ordered pairs and see if anything repeats, right? But that's not going to be the fastest way. We're going to use something that's called the vertical line test. And you're going to take anything that is vertical. So it could be your hand like this, or a pencil or a marker. And we are going to go across our graph to see if my vertical line or my marker ever touches 2 points at the same time. And you'll see on this one, it does not. Now I want you to imagine for a second, if this dot was moved over one, if it was right there, then my vertical line would hit 2 points at once. And it would not be a function. It wouldn't pass the vertical line test. But because that one's not there, it's right there, this one does pass the vertical line test. So this one is a function. What we're really doing there is we're checking our x values, right? Because if I had 3, 4, and 3, 3, that's 2 inputs of 3 that had 2 different outputs. So we're really doing the same thing. It's just you can do it in a more visual way. Now, if you look at this one here, you can see if I go across, like immediately, I'm going to cross 2 points at once. Some people like to actually draw the vertical line on. Pretend that was the straightest line you ever saw. Some people like to actually draw a vertical line on there, and you'll see right there that it does not pass. That's about -4. So the input of -4 has 2 different outputs, which doesn't work for functions. So this one is not a function. Okay, I did want to show you one more thing that you might see come up on homework or a test or something. One of these is a function and one of them is not. How do you tell? Well, remember, the whole rule is that each input can only have one output. So if you notice here, even though all of these are going to the same number, that doesn't matter. There's one output for 1. 1's output is 3. 2's output is 3. 3's output is 3, and you could keep going, right? Even though it's the same output, they each only have 1. So yes, this is a function. Now, one other thing that helps me remember if I'm trying to remember which one's a function and which one's not, I could write these as ordered pairs, right? Such as 1, 3, 2, 3, and I could keep writing the rest of them. If I were to graph those ordered pairs, what would it be? It would be a flat line at 3, right? So that would definitely pass my vertical line test. Now this one over here is basically just the opposite. Even though all the outputs are different, all the outputs only have one input, but that's not what I'm looking for. I want each input to only have one output, and this one has 4. See how there's 4 outputs for that? So this one is not a function. Again, if I were to write those as ordered pairs, my graph would look something like this. A vertical line. And is a vertical line going to pass the vertical line test? No. It literally crosses all the points at the same time. So that one does not pass. All right, I hope this helped. If you need some more examples, I will link a playlist for you. Thanks.